And we always suggesting, whenever you solve a equation, you need to verify your solution. So how to verify? Verify solution means you need to plug in the solution back to original equation and see if that make the original equation true. Okay, so let's do that. Verify. So 3 times x, replace x by 3 minus 5. That equals what? That equals 9 minus 5, right? That's given us 4. So left-hand side of equation equals 4. Right? This is left-hand side. Right-hand side of equation also equals 4. So left-hand side equals right-hand side, and then that's indicate x equal to 3. It is a true solution. All right, so you can look at the next 2 slides. That's just repeat what I just did. All right. So those are the 4 general steps for solving equation. First, you need to list any restrictions, okay, on the domain of variable. So someone consider domain is a big word. So what that means, domain means the collection of all the value of x. Okay, all the x is called a domain. So what kind of restriction we talk about here? For example, earlier we see x minus 1 on the denominator, right? And then, we know denominator can never be 0. So in order this expression still defined, okay, we have to make sure x cannot equals 1. And then this is the domain. So x can be any other real number except 1. Okay, that is called listing any restrictions on the domain. We will see the example. Second step called simplify. Okay, simplify again include eliminate parentheses, combine like terms. Step 3, if the step 2 result in the product of factors, okay, equals 0, and then we can apply 0 product property. Okay, after step 2, if you got an equation like this, x times x minus 3 equal to 0, for example, and then we can apply 0 product property, which is set each factor to 0. So either x equal to 0 or x minus 3 equal to 0. And then this we can further solve x equal to 3. Okay, that's what step 3 means. And then step 4 is always check the solution, which is plug in x equal to 3 back to original equation to see whether that will make equation a true statement. Okay, let's look at the example. First, definition. What is a linear equation in one variable? Standard form is ax plus b equal to 0. Here a and b, they're both both real numbers, and a is not equal to 0. If a equal to 0, and then that will become the constant, right? Just b equal to 0. So that's not a linear equation anymore. So why is called a linear? Linear refers to the exponents, the highest exponents on independent variable. In this case, is x is equals 1. So when the exponents equals 1, we don't write, okay, ax to the first power, we don't write that. We just simply write ax. They are equivalent. Just as the coefficient, b, we just write b. We won't write 1b, but they are the same, right? So a and b, they're constant, and x is the only variable in this case. That's why we call this kind of equation a linear equation in one variable. Ax plus b equal to 0. This is the standard form of linear equation in one variable. So let's see an example solving this equation. So let's look at this equation first before we start to eliminate parentheses, okay? We have a fraction as coefficient, right? We have fraction as coefficient. Normally, we do not want to deal with fractions. We don't want to deal with denominator, right? We like the whole number, we don't like denominator, fraction. So what can we do? We can find a way to eliminate both denominator 2 and 3. Okay, that's the direction we want to go. Okay, we want to deal with whole number only, or any expression without the denominator. That's our goal. So remember we earlier talked about the 5 equivalent procedure. Is any procedure we can get rid of the denominator? Think about. So we have multiplication principle, remember? Multiplication principle. If we both sides of equation multiply by the same non-zero number, and then the equation still keep equivalent, it doesn't change anything, but we can get rid of both denominator 2 and 3 by multiply the least common denominator, right? So 2 and 3, what is the least common denominator? It's 6, because 2 and 3, they are both prime number. There's no, any other factors. So the idea is we want to multiply both sides of equation by 6. Okay, so 6 times, this is the left-hand side of equation. Okay, and then 6 times right-hand side of equation. Okay, I just rewrite it. What I did, just both sides of equation multiply by 6. So this new equation still equivalent as original. And then we simplify, right? Left-hand side, 6, we eliminate these square brackets. So 6 need to distribute it in. So 6 need to times 1/2 and x plus 5. That's one of the term. And then minus 6 times 4. Okay, don't forget a 4. Right-hand side, 3 number multiply. I can multiply any of the 2, right? So I can times 6 by 1/3. We got a 2, right? 6 divided by 3, that's 2. 2 times 2x minus 1. So by doing both sides multiply by 6, I eliminate. This is a new equation I got. I don't have any denominator anymore, right? That's the goal, why we want to multiply by 6 on both sides of the equation. And then further simplify, 6 times 1/2, that's a 3, right? 3 times x plus 5 in the parentheses, minus 6 times 4, we can simplify, that's 24. And then right-hand side, still, we can keep parentheses, and then next step, we eliminate parentheses. So eliminate parentheses, we got a 3x plus 15 minus 24, that's left-hand side. Right-hand side, that's a 4x minus 2, right? And then combine these two. So I got a 3x, 15 minus 24, that's -9, right? Right-hand side, 4x minus 2. And we both sides have variable term. So I want to move all the variable term on one side and all the constant term to the other side. So I will move the 3x to right-hand side, right, by subtract 3x, right? Okay, I'm gonna do it here, kind of out of space, 3x minus 9, I just rewrite here, okay, equals 4x minus 2. So what I will do, subtract 3x from both sides, And then at the same time, constant term move to the right, move to the left, sorry. Add a 2, right? So left hand side, this term cancel, right hand side, this term cancel. So let's combine 4x minus 3x, we got an x. And then left hand side, -9 plus 2, we got a -7. So can we say -7 equals x as solution? No. Remember, I mentioned earlier, as a solution, variable has to put on the left-hand side of the equation. So we have to apply the interchange principle. Okay, switch the two sides. So the final solution is x equals -7. This is the final solution. Okay, and then next slides you can see step-by-step process, which is the same as what I did. And then verify, okay, plug in -7 to original equation. So left hand side simplify, right hand side simplify, and then they're equal. So we check solution equals -7, that is correct. So next one, let's look at the example, solving equations that leads to linear. So what that means, leads to linear. So in the process, you're solving an equation, you may get higher term, which is not a linear term, okay? However, you will cancel those terms, okay? So eventually, the equation still leads to a linear. So let's look at this example. Left-hand side of the equation, 2 binomial multiply. Right-hand side also 2 binomial multiply. So we need to apply FOIL rule, right? First term, 2y times y, that's 2y squared. FOIL, right? First, outer, inner, last, right? Outer term, 2y minus, times -1, that's minus 2y. Inner term, plus y. Last term, positive 1 times -1, that's -1. Right hand side do the same, right? First, outer, inner, last. So that's 2y squared minus 5y. 5 times 2y plus 10y. 5 times -5 minus 25. So we do have the quadratic term, however, both sides of the equation have 2y squared. So obviously we can use addition. Addition principle cancel those two terms out. And then combine like terms. This is minus y minus 1, that's the left hand side. Right hand side, combine like terms, that's 5y minus 25. Right? And then we need to move variable term on one side, constant term to the other again. So add a y on both sides, plus 25 on both sides. So we got left hand side 24, right hand side 6y. And then multiplication principle, both sides divided by 6. So we got 4 equals y, right? Again, we have to interchange the two sides. Right, y equals 4 as the solution. And then verify, right? Plug in y equals 4. So 2 times 4 plus 1 times 4 minus 1, that's the left hand side, right? So that's 8 plus 1, that's 9. And then, 4 minus 1, that's 3. 9 times 3. Left hand side, we got a 27. Right hand side, 4 plus 5 times 2 times 4 minus 5. So that's 9 times 2 times 4, 8. 8 minus 5, 3. So 9 times 3, 27. So since left hand side, right hand side, they're equal, so we verify y equals 4, it is true solution. Okay, so you can look at the next slide, which is the same as what I just did.